To build the 6 phototransistor line following module, you will need a soldering iron that can do electronics quality work. Get a temperature controlled soldering iron with a fine tip like this one. Watch our videos on how to solder and how to select an affordable soldering iron for building your robot so you don't end up wasting your money. When you solder, place the tip of the soldering iron into the joint so that it is pressing up against both the circuit board and the part, and then feed the solder wire into the joint. Do not keep the soldering iron on the joint for longer than 5 seconds, as it is quite likely that you will overheat and damage the printed circuit board and the part. I teach my students to count 1001, 1002, 1003, 1004, and then withdraw the soldering iron from the joint and allow the parts to cool. Do not attempt soldering when you are in a hurry or you have something else to go and do. Watch this video right through at least once before you start work on your line following module. Once you have watched the videos right through, you can place your tablet or your computer on your workbench and stop and start the video and use it as a guide as you build the line following module. When you build electronics, you need to wear safety glasses because as you clip the extra lead length away from the parts, small pieces of wire can accidentally get into your eyes. Wearing reading glasses like these with a magnification factor of 1 can protect your eyes as well as help you see the fine soldering work that you're doing very clearly, and this will improve the quality of your soldering. You will also need a stand to prevent burns. It is critical that you wipe the tip of the soldering iron absolutely clean on the wet cellulose sponge every time you pick it up. Wiping the tip of the iron on the edge of the sponge, just like in this video, allows the solder and dirt to fall into the recess area on the soldering iron stand. We use no clean type solder in the 0.9mm thickness from Mantech. You can buy a large roll for your school or club, or smaller quantities that are more suitable for hobbyists. If you look at the 6 phototransistor line following module printed circuit board, you will see a scored marking where you split it into 2 parts. With a fine pair of pliers or using a bench vise if you have access to a workshop, break away the narrower part, which is the light baffle. Use a file or a piece of sandpaper to smooth any rough edges. Mop up the dust from sandpapering from your fingers and work surfaces with a blob of press stick, and be very careful not to rub it into your eyes or breathe it in. The next step is to position the light baffle onto the main board using blobs of press stick to hold the part in place. In your country, press stick may be called blue tack. Before you start soldering, make absolutely sure the light baffle is perfectly upright and in the right position over the dotted line. Once you are certain it is in the right place and upright, apply the soldering iron and some solder wire to the exposed areas on the boards, which are called solder pads. Make sure the solder makes bridges between the solder pad on the light baffle board and the solder pad on the main board. After you apply solder to the first set of solder pads, it is a good idea to stop and check the light baffle board didn't move. If the light baffle board moved slightly while you were soldering the first set of solder pads, you can heat up the joint until the solder is liquid and shift things back into position. Make sure everything is positioned right before you solder the second set of solder pads. After you solder the second set of solder pads, it will become very difficult to move anything around without damaging the circuit boards. Once you have pinned the light baffle on both sides, it won't move around. If everything is where it should be, then bridge the third and fourth set of solder pads. The next step is to place the phototransistors onto the main board. Before the previous step, you will have noticed the white silkscreen markings indicating where the phototransistors and LEDs must be placed on the main board. It is not easy to tell the LEDs and phototransistors apart, as they look almost identical. The way to tell which is by looking through the front of the body of the part at what's inside. What we are looking at here is the phototransistor. Notice how inside there is a small black square chip of silicon with a tiny filament of wire. Now we are looking at a light-emitting diode. It looks like there is a blob of yellow glue inside. The body of the LED and the phototransistors are clear. Near where the pins come out, there's a ridge that is round with a flat marking on the one side nearest the short leg of the part. Here you can see how the short leg and flat spot are on the same side of the part. We start by placing the phototransistors on the line module. There are markings indicating where the parts should be placed and which way around the phototransistors should go. The round silkscreen marking for the LEDs and phototransistors clearly shows the flat marking on the edge of the rim of the parts. If one places the parts onto the PCB with a short leg through the hole closest to the flat marking, then the part will be placed correctly. In the first version of the printed circuit board, there was a little error on the silkscreen, which means we have to place the phototransistors on the board with this part the other way around for the circuit to work. You will know that you have the first version of the circuit board if the number on your board matches this number. If you have the second version of the printed circuit board that ends in a number 2, then the silkscreen is correct and you should follow the silkscreen exactly. If you have built the circuit on the first version of the board and you followed the silkscreen and it doesn't work, hand in your module at your nearest Mantech branch and they will give you another one. I would not advise trying to remove all the parts yourself and swapping them around, as you will probably destroy the printed circuit board and parts in the process. If you have not yet built the module and you have the first version of the board, then you need to remember that only the phototransistor side requires the longer leg to be placed through the hole that is closer to the flat indicator on the silkscreen outline. If the number on your printed circuit board ends in a 2, you're building version 2 of the line following module, and in that case follow the silkscreen outlines exactly. On version 2, place both the phototransistors and the LEDs with the short leg of the parts through the hole closest to the flat indicator mark on the silkscreen outline of the part. When building electronics onto a printed circuit board, it is usually correct practice to solder the parts down flat onto the board. For the line following module to work really well, it is essential to place the parts at a slight angle which will allow the light from the LED side to fall on the maze underneath the phototransistors and bounce back up into the phototransistors, which is how the optical line following system works. If you follow this diagram, the top of the LEDs and the top of the phototransistors will lean in slightly and will touch up against the light baffle, and you will get the best results. One approach to mounting the LEDs and phototransistors, if you have a decent soldering iron and you're good at using it, is to solder just one leg of each part in place roughly where it should be, and then, once they're all in place, touch the soldering iron to the leg of the part, remelting the solder as you shift each part into place. Another approach, which might be better if you're new to soldering or you're not confident the quality of your soldering iron will allow you to move parts around, is to use lots of press stick to place the parts exactly where they need to end up and then solder them into position that way. Whichever approach you take, in both instances take your time, don't rush, and only solder one leg of each part so you can move things around a little. Before soldering the other leg, check the part is exactly where it needs to be. Once you've soldered both legs of a part, it becomes almost impossible to move that part around without damaging the printed circuit board and the part. In this shot, we can see how the LEDs are tilted up against the light baffle. In this shot, we can see how the phototransistors are tilted up against the light baffle. In this shot, we can see how both ranks of LEDs and phototransistors lean slightly inwards towards each other, resting on the light baffle. The next step is to place the resistors onto the circuit board. The 220 ohm resistors with red, brown and gold stripes need to be placed on the PCB inside the ovals marked 220. The 4.7 kilo ohm resistors marked yellow, purple, red and gold need to be placed inside the circles marked 4K7. To prevent problems, we always solder one lead of the part, check that it has not shifted out of position, and then solder the other leg into place. The last step is to solder the connector strip into place. Some kits may have come with a longer strip of connectors than required. If this is the case, use the clippers to trim the connector strip down to the correct length of 8 pins, then place it on the board, holding it in place with blobs of press stick. Solder only one pin on each end, then remove the press stick and check it is perfectly straight before soldering all the other pins. Once all the pins are soldered, it will become impossible to move the part around without damaging the printed circuit board. The final step is to mount the line following module onto the robot, correctly orientated in this position. You will notice the connector is accessible and the LEDs and phototransistors are orientated inwards, which means that the footprint of the robot doesn't become bigger with the sensor in place. Please like this video and subscribe to our YouTube channels to watch our upcoming videos on how to connect the wires to the robot and how to configure the module to follow a line through the maze.